Well, hi, and welcome to my shop. Today I'm going to be looking at tube sockets. You can see a bunch of them on my table here. So the radio you see in the background has some kind of serious problem with the tube sockets, or so I've concluded. There must be something about the sockets used in that radio that has led to a problem that I cannot resolve using all the typical easy ways of doing it, cleaning and things like that. So there's five tubes in five tubes in the radio. This one up here I'm kind of ignoring. I'm just dealing more with the four down here on the circuit board. I think there's something about the construction of these sockets that is leading to this problem. So since I've never really looked deeply into sockets, I plan to do that today. So that's why I have a collection of them on my bench here. I have quite a collection of new or nearly new sockets that a couple people have given me over the years. So I have quite an extensive collection of various sockets. So we can look at each one of these, study how it's made, and then take a closer look at this, try to figure out how these are made. And ultimately I have to make a decision about this radio, whether I think I can fix it or not. At this point the answer is not. I don't think I can repair this radio. It would involve replacing all these sockets, which is not something I really want to take on. A highly risky operation. A little more for the hobbyist owner. If somebody were to own this radio and be a hobbyist, maybe that would be something you could take a run at. From a repair point of view, the cost of doing that, the risk, the chance of failure is so high. I'm really not anxious to go at that. But here's an opportunity anyway to examine sockets more closely, and maybe along the way I'll discover there's something else that can be done. Maybe the sockets don't have to be replaced. Maybe I've misinterpreted this whole thing. Maybe it's something else. A good number of you have suggested it's cracked traces underneath the board, but I'm not going that way because it just does not have the characteristic of that kind of problem. And I resoldered all the connections underneath this socket. It made no difference whatsoever. I couldn't see anything that suggested there was a break. I don't think that's the case. I think it's something going on right in the socket. So to examine these sockets, I've got my camera here. I can get really close to them so we can look at them in detail. The main factor, because I've already peeked at them a little bit, the main factor about these is, how is this connected to the part that the two pin contacts in here? And the answer is, in most cases, it's a continuous piece of metal from here up to here. And I suspect that's not the case in these. So let's take a closer look. There's all kinds of vintages here, so quite a range. Once I turn the close-up camera on, you won't really be able to see so clearly what I'm... yeah, you will be able to. What am I saying? You'll see it perfectly clearly. See? Clear as a bell. Okay, so which one should we pick? Let's start with the biggest one. The biggest one is this one. This is also one of the crummiest here. So these kind I've seen a lot of. They're made of two plates, two non-conductive plates. I can't think of the name of this material right at the moment. They're riveted together. A rivet there, and another one there. Two rivets holding the two plates together, sandwiching these parts into place. Now, we can imagine that this piece of metal is the same as this piece of metal. I'm going to pick something better to point it with here. In fact, I'm going to put this down so it's not moving all around. Boy, I got the focus really close. So the piece of metal that makes the contact here, see how the terminal wiggles with it? It's the same piece of metal, right? It's just been bent into this shape and then sandwiched into here. Very simple construction. These sockets are known for having shorts developed between the pins. Inside. So you get dirt and crap building up in the sandwich. You're getting more in the sandwich than you originally ordered. And in the end you can get conduction right inside here. And of course that's going to sound very much like what we hear with this radio, except it wouldn't be from wiggling the tube, although that would affect it. It would make clicking and popping sounds all on its own. So these are really common though. This is the big one. Okay, so we'll pick the next one here, the next biggest one. Well, I got 4 here, so we'll go to old. This is an old one here. Okay, so this guy is for a 4-pin tube. Now look, this raises the issue of different sizes of pins. I mean, great big pins are going in here. You can see how it's done. There's like a either side clamping action going to happen in there when you put the pin in. And again, it's one continuous piece of metal. This is the one we were looking at before. A little bit loose in there. Yeah. So I think you would call this one pretty solid, even though obviously it's got, we'll get it on camera there, it's got these two pieces with the metal bracket here fixed in there somehow. Okay, but that's easy to see. It's one continuous piece of metal. So next I have 3 here that are very similar. Let's look at this one. This is a porcelain one. This is probably a little bit expensive. Very nice looking. Oh, this one's been somewhere already. Solid porcelain body, and almost certainly again same metal. Like if you look at the kind of metal here, the color of it and all that, you look in there, it's kind of the same. It is the same piece of metal. There you can see I'm wiggling that thing. Continuous piece through there. Let's look at how this one's gripping the. Oh, these are really loose. You can really move them around. Probably loose to allow a little bit of adjustment for the pins coming in. It could be bent ever so slightly, just a little bit this way, that way. A little bit of movement is probably helpful in here. So you can see all they've done is taken a flat piece of metal and bent it around into sort of a C shape, if you like. Sorry, I can't. Yeah, it's sort of a C shape, and it's very, very common. There's another one. It's the same sort of deal as the C shape technique in there. So on that, what I imagine is happening. So here's the C shape, and then you're going to put in the pin. Oh, the wrong size. Okay, great big pin. Here's a pin. You're going to put in the pin. This is the 2 pin going in. Better show it coming down from the top. So I think these things are shaped. They're not shaped in a circle. They're shaped in an oval like this. And I think the idea is they're trying to make the contact right here. Right here. And then the springiness is because of the way the metal's been bent. So spring contact, biting edge on here. And then if we wiggle this around like I do, I'm sort of reviewing my techniques here to see if they make sense. So wiggling it around, which is what I do to kind of improve the connection. You can't rotate it like that. You can go up and down, and you can't even rotate it. You can just do this kind of thing with the tube. You can imagine it would kind of recut the edge there a little bit and rough it up. Would it ruin the... I don't think I've ruined any sockets until this radio showed up. So that's the idea of the clip. You'll see there's a number of different ways this is done. Okay, so this one, so you didn't look at this one. We're looking at this one, different camera. You see it's the same deal as the last one. Same basic construction. So in there is, let's call it the C grip. And again, it's going to be a continuous piece of metal out the back here, just bent. Okay. Now this one's tricky. This looks very similar to what's in the radio. If you look at it, first you see it's a silver colored metal in there. It's the same as that. And if you look long enough and study this long enough, you'll realize what they've done is they've brought a flat tang up into the up into here, split it, and then bend open the split. So I'll show you what I mean with my handy hands here. So inside here, they have the flat piece of metal coming up. They've split it here, and then formed it out like this. So when you put in the tube pin, it comes in like this, and then the springiness is this way. Then you have that cutting edge, kind of cutting in and gripping, and there you are. Now what happens if I do the rotating thing on this? Well, you can see some unfortunate bending down here, which would bend this out more and more. So I did the rotating thing with the tube. You know what I'm talking about, right? I'm talking about that, where I spin the tube around, something I've been doing for years and always kind of wondered about, but I've never had trouble with it, so that's why I do it. You would imagine that this could only loosen up the connection. Now it could be the metal is springy enough. Springy enough. There's enough spring in it. And there's limits to how far you can move the tube. You can only move it so far and get so much angle. Then in fact, you're not straining the metal. Let's talk about metal strain and stress for a minute. And let me get a piece of metal. I need a nice piece of metal for this. I need a piece of steel. Here's a piece of metal. How springy is this metal? So I'm going to try to hold it really tight here and bend it a bit and see if it springs back. This is a terrible demonstration from a reality point of view, but it's going to show you what I'm explaining. So as long as I don't bend it too far, it'll spring right back to where it was. That's if I only apply stress to the metal. I stress it, it comes back. But what if I pull it too far and let go? It doesn't come back, because now I have strained the metal. These are the proper terms to use. I've strained it here. I've changed it in here mechanically. It's no longer what it was. It's now bent this way. So there's a limit. There's a stress or strain limit. You can stress metal a little bit, but if you strain it, it's not coming back. The question is, am I straining the metal in here, by doing this kind of thing? So opening up the gap, it's not coming back. You would think, well, they're trying to design these things. I mean, there's no mystery to the people who designed these. They probably did all kinds of weird tests on them. Tubes in and out, how many times, all kinds of stuff, to see if this was going to last. On the other hand, the expectation is a tube might go in and out of this socket 4 times in the life of the radio at the most. That's all it's got to take, 4 trips in and out. Main thing again, continuous piece of metal, right from here right to there. I mean, this is a theme. Okay, now we'll look at some of these smaller. Hey, here's another one of these sandwich guys. Oh, this is a good example of a bad one. So these are hard to get the tubes in because there's not much guidance on any of these really. But sometimes the tube will float around here. It's quite hard to get them into the holes. There's only one central rivet on this one, so they saved a rivet. The way the tube is clipped in here is quite different from the others. Let's take a look. Oop, oop, don't fall over now. So there's the top, and looking in from the top, well, okay, so I thought those things were tighter together. The clips, they're quite open when viewed this way. Yeah, they're quite open. Now I've seen these, they're closed up. This looks brand new. It's never been installed. Let me grab a tube here. Do I have one just sitting on the bench? I do. There's definitely resistance here. I'm trying to push the tube all the way through. Oh, is that it? No. Have I got this lined up right? Oh man, why is it holding back? Something wrong with this socket? I didn't really expect this. It won't go in. I thought the tube would just pop right into this thing. Easy as can be. Why? What's holding it? It seems to be the metal, those metal clips. Wow, this is really gripping this tube. Wow. I'm getting weak in my older age, I guess. There it goes. Wow, that took a fair bit. I guess, there. So this is very, very common, even though I only have one of these to look at. This is a very common way. And we can see in this case, those clips, they were pretty tough to push this tube through. My thinking is the tube contact points, which you can see, they're actually very small contact points in there. Not the whole pin is involved, just a point of contact. Two points per pin in this one. If you leave the everything alone, you leave the tube alone, don't ever touch it, it just sits in one exact spot, then you can have some corrosion building up everywhere, but where the contact itself is, it's self-protecting a little bit. So I would think. Yeah. Okay, let's see if I can get this off. Man alive. You see, as I work the tube to get it out. Oh my gosh. It's the end of this socket. Wow. See, I didn't think much of these. Now I think a lot more of them. And then it's probably all closed right back up, or closed up exactly the way it was, probably. It looks like it's pushed open a little bit. Okay, enough of that. Let's look at this one. So this one has a different kind of grip in it entirely. This is a far more shaped arrangement. So it's, again, I think it's one continuous piece of metal down to the terminal. But they shaped the top so the chance of a pin going past, instead of going down the center, you can occasionally shove a tube in, and the pin actually go down the side of the connector there inside. So it's got sort of like a cup arrangement. You can't make that mistake. And it's one piece bent. It's basically the C technique, except the C is almost completely closed in there. Is it split on both sides? It looks like it might actually. Could be split on both sides. Could be like a clamshell arrangement in there. Yeah, it is. I can see one of them now. Hard to see actually. A little bit of bad lighting. So it's a clamshell sort of deal in a way. Again, almost certainly a single piece of continuous metal up in there. It comes with a large center post that you can use for various purposes. Spare terminal. There's another one. So this one's the same deal, only the clams are a little more open on this one. Wiggle the pins. Pretty. Well, they move around. So this one is made for a tube shield to go on. Now, we've looked at all these. These, I think, are examples pretty much every kind of way you can have a tube, or every style of tube socket commonly found. There's probably more. I don't have necessarily every possible one. And here's one right here in this radio. If we look at closely at this one now, what do we think we're seeing? So one thing that's caught my attention the whole time, I see a bunch of debris in one of them, is the color of these connectors, and the look of them. They don't look the same as the other sockets. And that's all small potatoes here. Let's see if I can just manipulate one of these. So yeah, this is so tough to do here. So what I'm trying to do, and I just noticed my tool has a funny bend at the end of it, and I want to move the those things. Now it's very easy to move. The question is, how can that be so easy to move when the bottom of it sticks out the bottom of the socket and is soldered up to all kinds of wires? Shouldn't that be fairly stiff? Trying to move this? Can I get back in the same one again? I'm trying to, yeah, see, it's just so easy to move it. Now, I know this isn't exactly a proof of anything, but I suspect what we're seeing is the failed mechanical connection between these top parts. I'll make a little sketch of what I imagine is in here. So you see the color, kind of a coppery color. Now, what can we see underneath the board here? Good question. What can we see underneath the board? Just don't want it to be on the antenna there in a bad way. What's happening here? Okay. So the tubes we're interested in, and you can see the tube right there. There's the socket. So, I mean, there's no room for these terminals to I don't look anything like this. This would be little wires coming through from the socket. This is the actual socket right here. That's the center of the socket, and these are the pins. And they're literally little thin pins, but all these sockets have large connectors because all these are meant for point-to-point wiring. Yeah. So these are meant to go on a board like this. Right. So the construction could be dramatically different inside them. Dramatic. Is there some drama here? Importantly different. Maybe that's a better way of putting it. So what I want to do, how to get this flipped right around, I think I want to look inside these as much as I can to try to spot how they're constructed. But first I'll make a quick sketch here. And just make sure you understand what it is I'm imagining in my head. Yeah, quick sketch. So most of those, so you have the socket part, and then you have the pin part inside here. The tube's going to contact, and there's a continuous piece of metal out here, and it's continuous piece of metal. In this case, I think what's going on, you notice these are taller sockets here too, a little taller than most, is you've got something going on, like it looks like a top hat. So up here we have the connector part. You can see it looks like this. It looks like this kind of shape. To me, it looks like something like that, and the tube pin coming down into it. And then how does it get out the bottom? Some kind of connection here to a thing coming out the bottom, a pin that gets soldered to the board now, as I realize. This is the problem. So an example of this kind of problem I'm shooting at is tube caps, vacuum tube caps. I'm just looking for one here. If I can just get my hands on one real quick. I can't. So a lot of tubes, as I'm sure you would know, have a cap on the top, and then they have a metal contact cap that goes onto it. And that top part is not made of copper or something like that. Copper has no springiness. Remember I was talking about stress and strain? With copper, it's almost immediate that copper gets strained and doesn't have any springiness to it at all. Steel is quite the opposite. You can bend, especially formulated steel, you can stress it like crazy and it'll come back. So lots of differences here between metals and the like. Steel, not the best contact material because it rusts. So we usually use zinc plated or some kind of plated steel. These could be plated steel. And then the cap, not on this radio but on older radios, the cap then has a wire coming off. The wire is never, this is the whole point, the wire is not soldered to the metal cap. The metal cap is steel, or maybe galvanized steel, or some kind of coated steel. In some way, you can't solder to it. Why exactly you can solder to all these things? So I don't have the story 100%, but these caps are not soldered. They're just clamped or crimped. Maybe another example of this would be cases where there's a ground lug, maybe on a metal chassis, and the ground lug is riveted to the chassis, and the rivet is carrying electricity. And over time, the rivet loosens up, a bit of corrosion takes place, and before you know it, that mechanical connection is failing and causing the same kind of static we hear in this radio. I'm thinking it's the same kind of thing happening. The same kind of thing happening in those sockets right at this point. And there's no fixing it by doing anything down here or anything up here. You've got to get right in at that. That's what I want to look for. I want to look for that. I don't want to smash one of these apart to find out what's going on. I'm going to try to look right inside it. So first we'll try with the camera here. See what we can see. Maybe that'll be enough. Kind of blast the light onto it. See what we can see there. Okay, I'm trying to see right down into it. And that would mean the light has to go right. This is very tricky because the camera has its own block. I might just be lucky to be able to manipulate one of these lights. We can see down in number 6 there, quite a ways. Can't. Maybe that's a focus problem at that point. Let me push the camera down further. I'm shading it. What's down there? There's something down there. So looking at the tangs themselves, okay, they don't look. Let me just explain what I'm seeing here. Okay, so in some of these sockets, you can see that it's a metal tang coming up that's been split, and so you can see these pieces. You can look in and see them like that. But when you look into this socket, you don't see these, and I can't make my hand turn this way. You see flat sides. Look at my hand. you see curved flat sides. So how does that happen? So there's some funny twisting in the metal to get it around to get the flat side there, or it's what I showed here. This is what I think it is, because I can't imagine how else it's made. And they put a different kind of metal in the top here that they think is going to be better for connections to the tube because it has some springiness. Well, then they put another kind of metal down here that you could solder to. And in the middle is a mechanical connection. So I made all that up. I don't know if that's really the case. Let's look in there again. See, the thing is, if I can wiggle those, well, we saw the bottom of them is soldered right in place. How and the other thing is too, if these things can deliver mechanical force right from the pin going in, like I'm doing here, and drive it all the way into the solder, then these are all targets for a cold solder joint. cold solder problem. This one doesn't seem to want to move. The other thing is it wouldn't be every one of these that would necessarily be loose. It would just take some. See now that seems to have some resistance. It's not flopping around. How much flopping can you get from something like this? There. Oh. It doesn't seem to have any floppiness to it. By floppiness, I mean I can move it and it will stay where I move it. It won't bounce back. So if there's a mechanical connection down there that's come loose in some way, how loose would it be? I mean, it wouldn't be very loose. Now that one, see, no, that's a shadow. Making it look like it's moving. I don't know if these are that floppy. Okay, so this is about as far as we're going to see like this. I'm going to try another way to see deeper in here and get a look at the condition of these contacts. And it could still be, look at the dirt, it could still just be dirt on these things, and I haven't managed to clean it in all my efforts. Yeah, let's see if I can get a more detailed, closer, better image of what's in there. Okay, I have a microscope somewhat clumsily set up here, blasting away some light. We're going to take a look. So the objective here is to look at a couple of things. One is the condition of those contacts, the surface of them. Is it corroded or covered in grease or some problem with it? And the second one is to look right down in the bottom to see where those tangs are going. Now, this gets really awkward. As soon as I touch this camera, everything goes wild. So let's see if I can manage to do this. I'm going to try to adjust the focus to go down deeper into the... this is just the weirdest... You can definitely see something down there, but this is a really hard thing to focus. So we're going to focus up here, and then I'm going to lower the camera to look deeper down. And looking deeper, I'm bringing it back, pulling it back up. I'm moving it about maybe 1/4 of an inch up and down. You can see it has a very, very limited focal plane. So the focal plane's in the contact area now. I'm up and down. I'm going up and down, looking at the curved contact area. You would think that would be self-cleaning, because then you just shove a tube in there, it would just sweep off anything that was in the way, and you'd have metal-to-metal contact in there. Now let's go down to the very bottom. Hold still here. I can't. So the camera is down. What's it bumping on? Oh, caught on a resistor here. Let me just move it off to the side a little bit. Camera's big to get in here. There. Okay, now I got it right down. What are we looking at? Nobody tell what we're looking at. Could be looking right in one of those things right now. I don't know where it is. I think I'm looking right down the very center of the center rivet, which I'm not really too interested in. So I'm going to push this away until we see there. That's probably a thing. Did I mention it's really hard to focus this camera here? Here we go. Oh, what happened? Just went dark. Let's go the other way. What are we seeing here? Are we seeing right down to the bottom now? Seeing something. I think we're seeing right to the bottom. question is, what are we seeing down there? And how do we know for sure we're going to the bottom? I'm going to lift this camera straight up if I can, and see what we're looking at. In fact, we're looking right. Okay, focal plane going down, down, down. Well, I all went out of focus there. Okay, I'll try to focus it. There we are. So the problem is the focus effect and the zoom are the same control on this camera. So as you zoom, it alters the focus. And you have to relocate the camera physically. It's really tricky to use. Okay, so what am I seeing down there? I don't know. I don't know. I'm seeing, but I'm not sure what I'm seeing. Let's just try another angle over this way. See what we can produce coming at a different. You come in this way. Yeah, this is a little better. Looks like some kind. It looks like a black hole. So that focus didn't work out. I'm focusing it, and the other thing is when you try to focus it, you have to rotate this control and moves it around. There we go. I had it up too high, maybe on there. Now what are we looking at? So it's going down here. Oh man, let me change the angle here. I have to get right above it. There, I'm right above it now. I'm looking straight down in there. What's down there? It's out of focus. Okay, so push the camera down. Push it down. Come on. Don't. So there's stuff in the way of the camera. Okay, we'll go down on this one. Anyone, somebody, anybody. What's keeping it from going down here? Just getting caught on adjacent components. There's a good view right there, right down to the middle. Now, can I make a focus come in? Ah, come on, camera. What an annoying thing. Hey, you can kind of see down this way. Easier. Except I can't get the camera right. Yes, I can. No, I can't get it right above one of these. So, what do you see down there? Anybody? Can anybody tell me what they're seeing? So we're down to push the focus down to the bottom. It looks to me like what I think it is, but you know how our brains work at helping us see things that maybe not even there. It sure looks like a continuous piece. And then how would they have connected the? So they all look the same. Look very coppery right down at the bottom. What's the red? What's the red color down there? Yeah, I had this thing focused up too close, I think, initially. There we go. They all look exactly the same at the bottom. So is that a rivet? Could you put a rivet through a little tiny thing? How would you make a mechanical connection? Or would they have actually tried to solder something down there? I don't imagine it. The pins get warm on the tubes, and the heat is conducted into the socket, and then the solder gets warm, doesn't have to melt. Just heat it up, and it becomes... Oh, look at that one. I'm looking at the one in the bottom right corner there. They all look exactly the same, but I can't tell what I'm seeing. Just get a glimpse of something. Huh. Okay. Totally different approach here. Let me switch off that camera. Totally different approach. I want to do something that will prove that the problem is some kind of failed mechanical connection inside the socket. Because if I can prove that, then I know the situation and I can comfortably say I'm not going to fix this radio. Unless I wasn't come up with some wild way of doing it. So I'm going to think about that. How can I come up with a way that's going to prove the situation in here? Might be easier than I realize. So I've set up a somewhat questionable test here to try to read the resistance right through the tube socket from the top where the tube pin goes in to the bottom where the connection is. You can see the bottom connection made here. This is connected to this socket. In the socket here I have a tube extender plugged in. And then you can see a black clip lead coming off of it. That's heading back to the meter. So it's pretty simple. The question is, what are we going to find out here? Now, this, a test like this is kind of wonky in itself. So there can be problems with clip leads, everything. So what I'm going to do is I'm going to wiggle that socket extender and see if this doesn't jump around all erratically. So it should be jumping already, in fact. A little bit of jumping is not going to mean much. So I'm moving it. You can see the clip lead here is moving as I'm wiggling it. There's nothing going on. There's nothing going on here. So it could be I just happen to pick a terminal that doesn't have this problem. But that's not supportive of my theory. So why don't we try another terminal here? It takes me a minute to get everything hooked up properly here, so let me do that. Okay, so I've been slowly working my way around two sockets. I'm on the output tube socket right now. In every case I've gotten essentially a zero, a stable zero, until this one. This one's different. Now, my problem is it what I've done here with my clip leads and stuff like that? So I'll show you what I've done. So I've got a short clip lead going to a really good connection on the board, so I don't think there's any problem with this. This guy comes out, clips to another clip lead. No problems here. What is it, Shadow? The sun is shining? This comes around to this style of clip because I had to use this to get onto the tube extender down there. So this is really good. I can't imagine there's a problem there. So I'm going to wiggle the connection now to the tube extender. Oh, look at it. Now, see, the problem here is I'm also wiggling the tube extender a little bit, and we know how fragile this thing is. So what I'm looking for is, can I get a reading to go down to, almost zero? I can't get anything now. This has come off. But let me just manually shove it on the terminal there. And I think it's on there now. So I saw a 4. So I'm not touching anything now. I'm going to bring this clip around. I'm going to clip it right onto the clip to the meter. Because what we're getting here is we're getting an indication that there's a bad connection here. I can't get it off here. But it could be just in this kind of stuff. So I'm just going to clip this on here. Yeah, look at that. What's the matter? Maybe my green clip lead's no good. Yeah, let's try that. Green clip lead. Lead's good. I've soldered my clip leads some months ago to try to make them much more reliable. So it's not the clip lead. It's not the clip lead. How can it be this thing? How can it be this thing? Really? Oh, son of a gun. Yeah, all I've been finding out is no matter how I connect it, there's a resistance showing up. Well, this is pretty useless, isn't it? Who would have thought that would be a problem? Just for that purpose, I have another one. Wait a minute. Wait a minute. This is what it comes down to this morning. These are just useless. Oh. Better I find it out now than later. I'm absolutely sure it's the... Yeah. Wow. These are just... Fortunately, I have some other colors here too. Maybe the black ones work better. My gosh, I can't believe it. It's just junk. They don't use these very often at all, like for instance now. Wow, okay, so that's another whole headache in my shop here. I didn't realize. I have one more. Is it worth checking it? Might as well. Might as well do the whole set. Do the whole thing. I was happy I had these things, even though I forget about them all the time, because they really make... I don't get it. That's a surprise. So I've been working away here with a couple of different approaches to trying to judge a couple things about these sockets. One of them is the contact resistance in the socket to the tube pin coming in. So I'm thinking if the surface is so badly contaminated or maybe has some kind of non-conductive patina on it now that just doesn't conduct all that well, I can probably detect this by doing what I'm about to do. So I have my ohmmeter here, kind of covered up by wires, but here it is. And it's showing an open circuit right now because it's not connected. So one lead is just going to the chassis, and I found one terminal on this socket which also leads to the chassis. So the resistance we're reading is going through the socket. So it's basically the socket, my test leads, which I double checked, they're all in good shape. So if I push this in, it's like pushing in a tube and reading the resistance of the pin as it makes contact. So here we go. And so it's down to 0.3 there. I'm hardly in. Now, does this remain stable? I'm just going to slowly push this in. Look at how stable it is. I'm not getting this to go into the socket at all yet. There it goes. Well, you know, so that says that one pin anyway, absolutely no problem. Right from the initial contact all the way down, it's showing a 0. I mean, I'm not testing every contact this way. Just this one, it's a little easy because it's, you know, goes to the chassis. So I got all kinds of conflicting things here. All kinds of conflicting things. So what I'm going to do is I'm going to again, for the second time, I'm going to resolder the both these sockets very carefully. Although I see absolutely no evidence that there's anything wrong with that. I'm at my wit's end again on this. Okay, so I'm gonna attend to that. Okay, so I've resoldered very carefully all the connections for the output tube. I also resoldered all these the second time around, resoldering all these. So let's try the radio, and just on the off chance that this was the problem. Okay, let's give this guy a bit of a try here, and we'll see what happens. Volume's down. It's on broadcast. There we go. Dim light says everything's okay. Give it the full power here. Volume up. Listen to that.
Alors, il faut qu'on soit capable de réfléchir à un modèle qui est différent. Ces sommes-là qui sont investies, ben, on les reçoit. La ville de Montréal, c'est savoir qu'on est pas, j'ai envie de dire, on n'est pas conscient de la question de l'itinérance parce qu'on n'a pas le temps. Du gouvernement du Québec, on est bien sûr dépositaire, on nous envoie des transactions avec les métropoles, avec les organismes terrain.
So what I think is happening is parts are warming up, mechanically expanding a bit. Hard to believe though. Should I touch that tube? I don't want to touch it. I touch it really lightly. Good, got rid of it that way. Well, I don't know what to say. I just don't know what to say. Sockets are shot. That's kind of what I want to say. Well, I walked out of my shop, and here I am again, just a matter of a minute later. I got a new theory. What if the problem here is not that there's anything wrong with anything, really. The radio has become extremely sensitive to fluctuations in one of its circuits. And how do you get the fluctuations? You move these tubes around. Intermittent contacts of a minor sort cause little fluctuations, and that fluctuation is carried maybe on a screen circuit through a bunch of tubes, and out of the speaker comes scraping noise. It doesn't matter which tube you wiggle, they will all result in this noise because something else is not suppressing the noise. And what might not be suppressing the noise? Capacitors, old capacitors, of which there's still 4 in this radio. And I'm really stretching things to come up with something here. Is it possible, if I just replace the tired old capacitors, and there's one right there, and there's one right there, right in the area of the circuit, that somehow this scratchy noise would no longer be an issue, even if it was still there? I mean, you can think of a sliding contact as a make break thing a lot. Maybe normally you just can't hear it. And abnormally you can. And what's abnormal? Old capacitors. Wow, I'm really stretching it at this point. It's not a lot of work to change out those capacitors. could be just one. Like for instance, if it were to be the screen circuit, let's suppose the screen circuit has become super sensitive. So if I were to replace the screen capacitor, maybe that would fix it. It's a big maybe. What else am I going to try? See ya.